Hi, welcome to the first session of the Open Security Summit in May 2022. And we start with a banger where Christian is going to talk to us about dependency management and supply chain security, which is one of those key topics that more and more is super important. And I hope you're going to get into graphs because, you know, when I think about this world, I always think it's a gigantic graph and we need to be thinking of this problem as a graph. But I'm really looking forward to the session, and over to you, Christian.
Oh, thank you, Dennis. Yeah, I'm very happy to start the May version of, or the May the May thing of Open Security Summit. And yeah, I'm talking about dependency management and supply chain security. So yeah, when you're on a Thursday afternoon or on Friday, and you're already in the weekend in your head, and you think about the mountains and going there and having fun and anything, and then your boss calls or your cert or whatever and sends you this. Your next task is to figure out which application uses Log4j. Maybe you can remember some weeks, or actually it's like months ago now, there was this Log4Shell, and you needed to immediately say which of your applications are using Log4j, which version are they using, what to do about it, how to fix everything. And yeah, I hope I can give you some answers to these questions today, and give you a small overview of the tools and things you can do in the area of dependency management and supply chain security. Short intro to me, I'm Christian Köberl. I work at Porsche Informatik. We are a quite big software company that's building software for Porsche Holding, which is one of the greatest car resellers in Europe, or actually, I think it's the biggest car reseller in Europe and one of the greatest worldwide. And I'm professional software developer since 1989. I do most of the things web development. My focus is on Java. You can find me on the interwebs under DERKOE, Twitter, GitHub, and also my web link is there. Yeah, so let's get started. Software today is built on a different level that it was built like 10 or 20 or even 30 years ago. We are all standing on the shoulders of giants. So we have lots of software that's running, but only a tiny bit is developed by ourselves. So lots of the software is dependencies. I just checked 2 of our applications. One is a TypeScript application, one is a Java application. And I just looked there and looked how many code is from us and how many code is from third-party dependencies. And as you can see, there's just a tiny small thing there where the third-party depends, where your own code is. It's under 5%, even under 1% probably. And there you can see that most of the code is third-party dependencies. So nowadays, lots of the code is open source third-party dependencies that you get with your applications. Oh, while I'm talking, if anybody has a question, just put it in the chat or just shout it out if you want to. The other thing is dependency count. There's this SNCC study from 2020 where you can see the dependencies of your dependencies, actually. So these are the packages that are in NPM or in Maven Central or in any other of the ecosystems. And you see that especially with JavaScript, you have a lot of dependencies. So a typical JavaScript package has 10 dependencies. Is the median value, and 683 transitive dependencies. So there are some packages that have lots and lots of dependencies, and you are the one who is responsible for managing them, because you are getting all these dependencies, putting them in your code or in your application and running them in production. It's better with the other ecosystems like Java and Python, and so they don't have that many transitive dependencies, but with JavaScript, it's really crazy. This, for example, is the Next.js dependency graph. So this is just a graph of all the dependencies of Next.js plus the transitive dependencies and the dependencies of that, all the transitive dependencies of Next.js. And you see that, you can't really see that here, but you see that the the pointers are going in and out and in and out again. So they are interdependent, which also brings stuff like version management and a big chaos around that. So it's not very easy to manage those massive dependencies. And then there's also this trend of getting lots and lots and lots and lots of new packages. This is also from the SNCC report from 2020. And you can see that especially NPM is creating lots and lots of new packages every year, like over 300,000 in 2019. And I think they're now even over this value. So we are seeing like 500,000 new packages, these are not new versions, these are new packages that are created every year. Because there's lots of developers and the community is quite big there. With the other ecosystems is always smaller, but there's even that, like 100,000 new Maven packages in 2015 is also massive. So you have to cope with all that and see how it's going there. Also, the dependencies increase, which is quite clear, because when you increase the amount of packages, then also the dependencies will, the vulnerabilities will increase. This is a report from White Source, where you can see that the vulnerabilities of open source libraries increased massively, especially 2020. And I think the trend is also going up further with 2021 and now 2022, as we saw all the vulnerabilities in the last 2 years. Here is another view of the same thing by SNCC, where you can see the vulnerabilities per ecosystem again. And you can also see that NPM and Maven are leading, especially NPM is quite up, but also Maven is quite leading because lots of people are using Java applications. They don't have so many packages, but they have bigger packages. And so a bigger package has also the possibility to create more vulnerabilities than these really, really tiny NPM packages. And then there is DevOps, and there is the new kids on the block: Ansible, Terraform, Docker, Kubernetes, Helm, and each one of those has dependency management in there. So you have Ansible modules, you have Terraform providers and modules, you have Docker and stuff like that. Everything is, again, dependencies. And you have to, now as a development team, you also, when you're in the DevOps area, so you also run your application, usually you have to at least have 1 or 2 or 3 of those technologies there as well. So yeah, one solution to this problem is what most people, what I call, is continuous updates. So you just try to keep up with the updates churn and keep up with the edge, and also always update your packages so that if there is a vulnerability, you can easily upgrade to the next version. And if there is any vulnerability found in an older version, then you don't have any problems because you're already at the newest version. And another thing is that sometimes security vulnerabilities are announced after they are released. So, and if you're already updated to the new version, then you're already safe when the vulnerability is announced to the public. So here you have a better standing if you use one of these systems. And the most used systems in this area are Dependency and Renovate. Today I'm mostly focusing on Renovate. Dependency was a company and was bought by GitHub, and so bought by Microsoft now, and is fully integrated into GitHub. Has a very good standing on the GitHub workspace. It works really well with the GitHub ecosystem, but it also works now, I think, with GitLab. So you can also integrate GitLab there. Renovate is its own tool, so you can run it. It's also open source, so with especially quite interesting for the Open Security Summit. It's open source. You can run it on your own laptop. You can run it on your own servers. But there is also a cloud version for that, which works with GitLab and GitHub. I think most people are using it with GitHub. I like Renovate a little bit more because Renovate has a little bit more features, And it also has lots of more systems to integrate. So it also can Terraform. It knows how to update Ansible and all the DevOps tools as well. Dependabot is mostly focused on developmental languages like JavaScript and Java and so on and so forth. So yeah, let's have a small demo how Renovate works. So I've prepared here a small GitHub repository, and this GitHub repository is actually just a small application that has lots of dependencies in there. So I have here a package.json, and in the package.json, there's one dependency to Prettier. Then we have a POM XML, which is a Java dependency management tool. And there you can see we have a Spring Boot version, which is 2.5 and so on. So we have lots of different files. There's a Terraform file there, a Docker file, and so on. So we have lots of different things going on there. And what I also did now, I installed a GitHub application, a GitHub app that's called Renovate. So you can go to your account, go to the GitHub apps, and install the GitHub application to your repository. You can see it. You can see it here. Oh, you have to authenticate, of course. And you can see that Renovate is installed in this repository. And as soon as a Renovate is working for your repository, it sends you pull requests. And the first pull request Renovate will send you is a configure request. So it says, configure me so that I know what I should do with your repository. And this configuration is done in a file called renovate.json. So what Renovate does, it creates this Renovate JSON file here. And it also already in the pull request says, okay, I detected these dependency files here. And I just bump it up another one. There, I found a Docker file, which is a Docker file. I found POM XML, which is a Maven. I found a package.json, which is npm. I found another Docker file with a regex special one, and I found a Terraform file. And what's also quite interesting, Renovate also already says what it will do after this pull request is merged. So it will pin the dependencies, update the JDK, and so on and so on. So a lot of things is quite already in this pull request. What I did in this pull request, I created a second commit here, where I did some other configurations. So I ignored some PR hourly limit so that we can see all the PRs here. We can have a look at the documentation in a minute to see lots of these things that you can configure here. But what I now want to do is I'm gonna merge this pull request. And when I merge this pull request, I get this Renovate JSON file here, in my application. And in this Renovate JSON file, I configure the Renovate bot. And as soon as Renovate detects that, we will see that Renovate will go in there and create pull requests for me to update these dependencies. So while Renovate is working, let's also have a look at the different dependency files. As I already said, there is a POM XML and the package.json. But let's have a look at the Terraform one. I don't know if you're all familiar with Terraform, but Terraform also has like providers and versions and stuff like that, which you usually put in somewhere in the Terraform. But versions can also be somewhere hidden in some resources. Resources in Terraform, something that Terraform creates in the cloud. But here up here, I say, okay, there I have the required provider. And I want to have the Helm provider. So I want to deploy something to Kubernetes with Helm. And I'm using the Helm provider with the version 2.2.0. And this is also some kind of versioning magic. I think this special thing here means I also want the updates, the minor updates here. Renovate will detect this version here and will create a pull request for that. What's also quite interesting, Renovate even sees this version, which is actually kind of just data for Terraform, and will also update this version here of the Helm chart that is installed into the Kubernetes cluster in this case. For a typical Terraform file, this is just data. So this is nothing different than a repository, but Renovate also knows Helm releases in Terraform files. So sometimes like dependencies are in other dependency management systems or in other languages, and Renovate will also find these kinds of stuff. Oh, we already have 8 pull requests. Okay, we'll look at it in a second. I just look at the last one I have here as a Docker file, and here in Docker file you can see that there's also a dependency up here, like the Docker base image. And as you can see here, I've put in a special comment in this line. So with this special comment, you can actually update anything with Renovate. Anything that's a text file, you can update with Renovate. And it works like that. You just put a comment in there, whatever this language uses as comments. In Dockerfile, it's this hash mark. And I say Renovate, and then I say, okay, I want the data source GitHub releases. And I say, okay, jattach. So this is the repository. As soon as there's a new release, please update this version down here. And this works with this special configuration. You can have a look at that. I'm not going into syntax details, but you can say, okay, I have a regular express manager, and then you just put in some regular expression. You can put the regular expression for the file and then for the string that's in there. And with that, you can update anything actually. So even your own languages and whatever you want. Okay, so let's look at the pull request that Renovate did. And yeah, it found a lot, as you can see. First, what I told you is like it will update Helm, and it did. So it updated Helm from 2.2.0 up to 2.5.0. So this worked. And it also updated the Helm chart in Helm in the Terraform file. So in this case, from 1.1 to 1.8. And what's also quite interesting, if there are release notes in GitHub, then you also see the release notes here in the pull request. So in your own pull request, you see the release notes from a third-party dependency, which gives you a lot of confidence there. Okay, other stuff, for example, Maven. This is a Docker base image. So here the Docker base image was updated from this special version to this version. As you can see, I pinned the version of the Docker image with the SHA, which is quite a good idea for production so that you have reproducible builds. If you build this application twice, you get the same result. If you omit the chart, then it will just use the Java 11 version, and you won't get any. You will get updates automatically, but you don't know which base version you had for building that. Okay, so as you can see, Renovate is quite good for that. And as soon as I go in there and merge something, I can merge the pull request, and I can go in other pull requests and say, okay, I want to rebase pull request if I want to. I just mark this checkbox. Renovate will rebase it, and it will fit on the top of your branch on your Git main branch again. This is the Renovate workflow. Usually, what you do is you have lots of unit tests or integration tests for your application, and with that, you can have a lot of confidence for updating your dependencies. And we do this with many of our projects already. So we renovate the project. The project is tested, even probably with a feature branch deployment is deployed somewhere. An integration test is run against it, and we can confidently update our dependencies to the next versions. Okay, so what Renovate also does is it creates a dependency dashboard. If you want to, you can also deactivate that. And there you can update single dependencies. And with the configuration file, as I said, you can do a lot of other stuff. There is the documentation about it. It's under docs.renovate.org. You see how you can get started. And here is the big configuration part, where you can see all the configuration things that you can configure. There's a lot of lots and lots of configurations you can do. You can customize commit messages and so on and so forth, the author, and so on. You can also use groups here, so you can group dependencies together. Like there's Angular has different packages that all make up Angular and they're released together, and you can group them together. But Renoways also has this preset groups so that you don't have to mess with that, but you can group your own on-premise dependencies and do stuff like that. Okay, so that's Renovate, and I would strongly recommend that you use either Renovate or Dependabot in your applications and for updating your infrastructure as code as well. So let's go back to the presentation. Any questions so far? No. Okay. Okay, this was the first part you need in your recipe to get your weekend back after Log4j. Let's go on. The next thing I would recommend is to have a look at open source health. So if you pull in a dependency, just don't pull in any dependencies you have. Think about pulling in dependencies before you do. There are quite good websites for open source confidence or open source package information. There is Open Source Insights. It's under deps.dev. And with that, you get, as you can see, a lot of information about the packages. And I think we can even go there. Yeah. And you can go there and just search for open source packages. And there you can see you have lots of informations, the dependencies, people who are depending on that, or things that are depending on that. You have versions, when it was releases, and with all that you can see that there are you can see a lot of stuff. You have owners, you have contributors and stuff like that. So with that information you can see if a package is maintained, if there are releases and stuff like that. Something similar is by Sneak, which is also free to use. There's a Sneak Advisor, and they also create this package health score, so you can go in there and see how well is the package maintained, how popular is it, and with all this you can see if this if you can be confident that they will handle security updates well, or even still exist in some months or years. And this is under Sneak Advisor. So, okay, this was the second ingredient. Look at the open source dependencies and see how they how well they are maintained, how secure are they. The next thing I want to show you is software bill of materials, which is also one of the good pillars that you can sleep well on your weekends. Software bill of materials is actually, what is a bill of materials? A bill of materials is just a list of components, a list of things, dependencies, of all the dependencies you have in your software. A bill of material was the original term. Is like when you build something, a car or whatever, then the bill of materials is all the little parts, all the parts that the car is made of. And the same here goes for software. So a software bill of materials is all the parts software is made of, including your Docker base image and everything, including versions, including all transitive dependencies, and also usually including license. So with that, you can easily see what a software is made of. I think the American government now requires you to ship a software bill of material when you ship software to the state and to the states. And I think in Europe, some countries are preparing for that, or even have already some policy like that established. So how can you get a bill of materials? Currently, there are like there are two competing standards regarding software bill of materials. One is the Software Package Data Exchange, SPDX, and which usually comes from the area of license management, copyright, and stuff like that. And the second one is Cyclone DX, which is from the OWASP group. And Cyclone DX comes more from the securities perspective of it. So both standards are well established, and usually there's even some transformers that can transform one into the other and back. It depends on which tool you're using. They usually spit one of those and maintain one of those. So yeah, so these are quite good standards, and we can have a look in the demo how these files look. So we can go to demo. I will next show you some tools for creating these SBOMs. SIFT, GRIPE is from Anchor. GRIPE is a security scanner that's using the SBOMs from SIFT. And then I will show you a short demo of Dependency Track, which is an OWASP project, OWASP tool, where you can track all your dependencies, including using SBOMs. Okay, so let's first have a look at the website of SIFT. So SIFT has no real website yet, so it's just a GitHub repo. So you can see it's still quite early, but for its early thing, it's really major, and it works quite well. What SIFT does is it's a CLI tool for generating software bill of materials. So what it does, it scans file systems for stuff, finds dependency information, and creates SBOMs out of that. Yeah, so it's a CLI tool, so you have to go on the command line. So here I am at my command line. I have Docker running in the background because SIFT usually scans Docker images, but I will show you in a minute that you can scan anything actually. So how you're going to use SIFT is you just install SIFT. You can read how to install it on the homepage, and then you can just run it with SIFT and then a Docker image name. In this case, Node.js in the version 16 in the variant of Alpine. So I'm going to run this. As you can see, for just a bit, SIFT scanned the image, and it spits out lots of packages. And as you can see, there is APK packages, which are Alpine packages, and there are NPM packages in there. So it finds packages from different ecosystems. And yeah, with that, you see that they're outputting a table. You can also use SIFT to output it in a different format. For example, Cyclone DX, which is one of the formats we talked about. And I can just put this in a file, Cyclone DX dot, I think it's XML. And we can have a look at that. Visual Studio Code here. So yeah, this is an XML file, Cyclone DX, and the same information that was in this tabular data here, you can see here in XML format. So you can always see the author, the name of the package, the version, and you can see there's a license in there. There's this CPE, which is kind of like a pointer, an URL to a package. The Perl, which is another version of a pointer to a package. In this case, it says package is an NPM package, and then this add promisify in the version 1.1.3. And the same thing is here called encoded in the CPE. And there's external reference and all the stuff. This was just found by SIFT out of the binary. It was just a Docker file, a Docker image here. So yeah, this is Cyclone DX, and maybe we can also have a look at SPDX. SPDX, if we just go SPDX here, it will pull out a text file. SPDX is a text format. So we can have a look at this, SPDX txt. but there's also a JSON version for that. So first we'll have a look at the text version. So there's a header, and then there are all the packages again, also with these external dependencies, and there's also the Perl in here. So the Perl is used by both tools. But most people nowadays use the SPDX JSON version, which looks something like that. So there is just a JSON representation of this list of dependencies. And there you can see that this is a special representation because first of all, there's all the dependencies or all the packages, and then there's like a graph of all the interdependencies between those packages. There are the packages, and down there, then there are the files, and then there are the relationships between the dependencies.
Hey, Christian, just a quick question. Is there a way to visualize this? Because now it's on this kind of graph format, right? So you should be able to bring into nodes and edges and start to run analysis on it.
Yeah, I think there's some tools there for that. But we have a look at the OWASP a dependency track, and there you can see that you can do a lot of analysis with these files there. Yeah. Okay, so with Sift, you get like these files. Actually, a better way to get these files is to create the SBOM from your application itself while building the application, because maybe some of the stuff is lost, because when you have an application that is written in Rust or something like that, then when you build it in a binary, you don't have the dependencies in there. So you have to create the SBOM while building the application, and then you can put it also in OWASP dependency track for that. But this is for applications like third-party or base images or Linux or whatever. You can use Sift to create the SBOM for that, and then you can also merge SBOMs with tools. Even Sift can merge SBOMs, which is quite handy. Then you can add all the dependencies from different tools. What I also wanted to show you is you can also run Sift against a file. So let's go here. I think I have just a demo from another talk I gave, and here under under Java Real World app, I have just a Java app, and there under target, there's this Java Real World app jar file, and this jar file is just a Java executable Java file. And here you can also go like Sift file, and then this file, and Sift will scan this file, and it will find all the Java archives that are in this file in there. And it will, if you have a Java archive and there's a Ruby archive in there, it will even find those. So yeah. Okay, so with all that, I can also show you Gripe for a second, which is, I will not focus on that, but you can use Gripe the same way as you can Sift with Sift, and Gripe will just use the information from Sift. It will actually internally call Sift, and then and as you can see, Gripe is also checking a vulnerability database. Gripe is a simple vulnerability scanner which will just match the SBOM information with some vulnerability database from Anchor. You can also feed it with an SBOM, but you can, as I said, you can also feed it with a Docker image. And in this case, I just put it in the node 16 Alpine, and it had found no vulnerabilities. Let's have a look at the normal node image, which is based on the Ubuntu or Debian, I think. The image is a lot bigger, and you can see that there are lots of dependencies, lots of security vulnerabilities in this package. Usually, most of the dependencies, security vulnerabilities cannot be exploited. But anyway, you can see that in the Debian version, there's a lot of more vulnerabilities than in the Alpine base image. Okay, so let's see how we can visualize all that. And You can, after you created these SBOMs, you can import them to Dependency Track. Dependency Track is an open source project from OWASP. You can install it. It's a server. It is a database, and it also gets some dependency information from the internet and from different sources. And it shows the components which are in there, and it also indexes all the SBOMs. And the really cool thing about that is when you have all your applications indexed with Dependency Track, you can just go in here and say, I want to see who's using Log4j Core. And I see, okay, these are all my applications that are Log4j Core, and I see all the versions. And here I see the Docker images that are using that. So with that, you can analyze your dependencies. You can see what dependencies are running. And this is quite a powerful feature. If you're using Kubernetes, there's also a cool tool called SBOM Operator by Christian Kotzbauer, which is a really great tool. And this tool scans your Kubernetes cluster for Docker images, creates an SBOM for each Docker image, and then puts them into Dependency Track. And this is actually what our Dependency Track is doing. So all our Kubernetes clusters are now scanned, and all the Docker images are scanned in there, and we put all the SBOMs with this operator into the dependency track, and now we can quite easily say with one search which application is using which dependency. Okay, so Christian also created another operator which is called the vulnerability operator, I think. Here it is. And the vulnerability operator does the same thing, or similar thing with gripe, and it outputs the data to some metric server, so you can see how many vulnerabilities do you have. But I think the other way with the SBOM and dependency track is a better way to handle that. Okay, let's go back to the slides. Okay, the last thing I want to talk about is supply chain security, and this is quite new. It's not that very major, and yeah, we have to see how the next months and years go here. Everybody knows the big incident, or one of the big incidents, SolarWinds that happened, but there were others in this area as well, and yeah. All the things that were happening there, where it was some code was put into software usually via the build pipeline or something else, that was then distributed to by the vendor itself to the customers, and then the attack occurred. So in this case, supply chain security means like watch all your dependencies, how they're performing, see if something is going on there, and find a solution. In the area of supply chain security, there's currently one thing going on like SALSA, and SALSA is supply chain levels of security. You can think about it like CMMI. It was like the maturity of software development. So you get different levels of security from SALSA depending on how you how secure you are. So if you have a source code repository, if you have reproducible builds, if you have a package repository, and so on and so forth. So here are the 4 levels, and yeah. So in future, I think you can go to your vendor and say, I want to have level 3 from your packages. I think currently we're not there yet. And there's another tool which is pretty great. It's called Sigstore, and Sigstore is here to so that you can sign your software quite easily. And there's a tool called cosign, a container sign, which you can just run, and then it creates a signature of your container and puts it in your Docker registry, so that later when somebody is pulling a Docker image, maybe from another registry or from somewhere else, she can just validate your signature and see if the software is from you. This is quite powerful and works quite easily. And I think the next Kubernetes version, 1.25, is the first one where all the containers and everything in Kubernetes is signed with Sigstore. with cosine. So I think this is getting major as well, and I think you have to look at this kind of software and see how this behaves in the future. There's another cool thing going on called Socket, which is a supply chain security tool for the JavaScript environment. But they're planning to move also to other environments like Java and Go and other main languages. And what they do, they also provide this open source security checklist. So supply chain, this package React has a good supply chain security, good quality and stuff like that. But they also have a GitHub app which checks your dependencies in the pull request before they get merged if they have any supply chain security issues. They're a startup. Currently, they're free, and they're founded. I think in the future they will have a paid version of that. But I think this is also one of the tools which can protect you and your developers from this kind of stuff. And I know it's from one of the main developers is Feroz. It's one of the guys that was also running JavaScript JS Party podcast, and he's very, very well known in the JavaScript environment. And I think this could be a real good thing for the future. You can use it today. You just can install your GitHub app and make your applications already secure, more secure here. So to sum up, what I can recommend is scan your dependencies for known vulnerabilities. We use commercial tools for that, like JFrog, X-Ray, but you can also use open source tools like Swift and Gripe. You can combine Swift with the OWASP dependency track, and with that you can easily find known vulnerabilities in your software. I would strongly recommend to automate dependency updates, because then you know there's a new dependency there, and usually for us it's a lot easier when there's a security incident to update to a new version. When you're like on a version that's like 5 years old, and then there's a security incident, and it's also for your old version, then it's usually really, really hard to upgrade, and then you usually have to mitigate somehow else this security incident. Yeah, monitor the project health of your open source dependencies, see how they go, check them before they pull them in, use one of those tools to check them. Check the fingerprints of your dependencies. Cosine can do this now, for example, for Kubernetes, but usually all the ecosystems already have tools to check the fingerprints, which most people don't do. For example, Maven does this. Maven checks the fingerprints automatically. All the Linux package managers do this automatically, but for NPM, nobody checks your fingerprints or signatures or whatever. So these ecosystems have to get something running there. And I think this is also one of the major points for the future. And the last thing is, I didn't talk about this a lot, is invest in reproducible builds. Invest in stuff that you can create this with the same source code, create the same binary output. And this is not that easy because you have to look at all the dependencies and everything. But when you use Docker pinning, like I did with the shoot charts with 65, and stuff like that, you already get near to reproducible builds, which is usually quite good enough to be confident that your application will run in production. Even especially when you make a change, like when you have small security incident, you create a small, make a small change for an older version, and you can easily say, okay, this thing will also work in production. Okay, then I'll say thank you for everybody listening. As I said, you can find me here. You can also follow me on Twitter. And on the next 2 slides, you find all the sources I have and all the software tools. And the talk, the slides are already on my homepage here under talks. You can also already download the slides here. Okay, thank you.
Very cool. No, this is really amazing stuff. It's great to see a lot of progress, right, on doing this. So what's next? What's the next innovations that are happening on this space? And actually, the integration also with the CI pipelines. I think that's also quite critical, isn't it?
Yeah, I think one of the things that's coming next is to combine these different things into one thing that's working quite well. I think vendors like Sneak and others are working on that, so that all these different sources and tools are combined so that you can have a one view of your software, of the health of your software, including all the dependencies, including all the signatures and stuff like that, so that it's not that hard for each and every developer to get this really running, and that everything works quite well.
Cool.
I think there's a question from Vinod Anandan. Hope I said it right.
No, I think yeah, go on.
Hey, Christian, great presentation. Thanks. So I have a comment on what Dennis was asking before, but at the same time, I have a couple of questions for you. So yeah, Dennis, for your question, right? Yeah. So Cyclone-DX can support graph data. I mean, the relationships as a graph data, and if you have a Cyclone-DX SBOM with the graph data, dependency tree can show you the graph representation of the relationship, right? Like, so that's the. So the question, Christian, more about how do you handle the stale pull request issue with the renovate and depend about or things like that, right? Like once you have so many automated pull requests with all these other important pull requests, so-called, people tends to keep it in the backlog or stay there, and how is there any tips and tricks how you are currently handling it?
What we usually do, we group all minor dependency updates, all minor and bug fix updates into one merge request or one pull request, so that the team usually only has to have because in 99% of the cases, these dependency updates work out of the box. So the minor updates usually just work. You don't have to have big troubles with that. And then you have the major updates, which we put into different pull requests. You can quite easily do this with Renovate, but group all non-major, I think it's called. And so this is one of the things we do. For the people that we have different development teams that work in different with different methodologies. For those that are sprint based, what we usually do is we merge all, or we try to merge most of the dependency updates at the beginning of the sprint. So after the sprint starts, the dependency updates are merged, and then you have you can be quite confident at the end of the sprint that everything works, because then you have like 2 weeks or 3 or 4 weeks where everybody was working with the new dependencies and finds finds all the issues around that.
Okay.
Yeah.
So at the beginning of the sprint, everything is merged and your team will focus. Okay, it's more confidence on the updates to test it. Okay, that's it. So regarding the generating the SBOM strategy itself, right? Like have you already tried build SBOM using build plugin, and is there any particular reason to prefer the SBOM generation from reverse engineering or fingerprinting kind of things, right? Like, I mean, this is something that traditional SEM vendors already does, and one of the big challenges, false positives and false negatives with those approach, right? Like, is there any particular reason to still go with that approach compared to a build plugin based SBOM generation?
Yeah, as I said, I think the best thing is to create the SBOM so that the developer or the development team creates the SBOM while building the application. So that's the best thing. But the world is not easy, so you have to have third parties and stuff and everything, and also the Docker base images sometimes come from somewhere else and stuff like that. So usually you have to combine both techniques. So you have third-party SBOMs plus the generation of SBOMs with your software development tools. For example, like there's a Maven SBOM plugin which creates SBOMs for Java. Then you have for Node.js, you have an SBOM tool, and with that they combine, then you combine those two, and then you combine the one of the base image, which you scan with SIFT, and then you get the correct SBOM for your application, or at least what you think that is the correct SBOM from your application. I think, but as I said, the best way is to create it during the build. Okay, any more questions?
Cool. No, I think we're good. I'll wrap it up, man. Thanks a lot. This has been pretty amazing, and I hope you come back and present on the evolution of this at the next couple of summits.
Yeah, hope to come back. Yeah, maybe something else in the area of security. Yeah.
Brilliant. I mean, we should probably do a panel around these topics, because sometimes it's good to get a lot of the key individuals that are really thinking about this around a couple of topics. So it's very good stuff.